All right, this is section 2.4, your final section of rational numbers. This is calculating the square root of rational numbers in decimal or fraction form, as well as estimating the square root of non-perfect square numbers. So the first question said has three people: Max, Linda, and Jamila. So Max, if we read what he said that the square root, Max said the square root of 6.4 is equal to 3.2. And of course, if we think about just Max's for a second, he is making one of the most common mistakes with square roots, that the square root does not equal dividing by 2. Okay, and a lot of people look at the square root as saying, well, what's half of that number inside there? And it's not that. The square root actually means what number, when multiplied by itself, gives you 6.4. Okay, what number multiplied by itself is 6.4? So obviously, 3.2 times 3.2 is not going to be 6.4 because 3 times 3 is 9. So therefore, it is impossible that 3.2 times 3.2 would give you a number less than 9. So Max is making the common mistake of simply dividing by 2. Linda, on the other hand, said the square root of 6.4 is equal to 0.8. And this is more reasonable because Linda knows that 8 times 8 is equal to 64. So therefore, she's thinking, well, 0.8 times 0.8 must be a variation of 6.4, and I'll just put, or 64, so maybe because there's decimals in this number, one decimal in this number, I'm just going to put one decimal in the answer. And that also is incorrect. And if we think about why, if I interpret what this would have said, this would have said 80% multiplication is of, and then we'll just use money, 80 cents. If I interpreted 0.8 times 0.8 as 80% of 80 cents, well, I know my number is going to be less than 0.8 or 80 cents because if I only have 80% of 80 cents, it has to be less than 80 cents, and my number would be, therefore, less than, my answer would be less than 80 cents. Oh, that's right. I got that wrong backwards. But anyway, you get the idea. So Linda's wrong. Linda's just knowing that 8 times 8 is 64 and making a variation of that. So Jamila, by default, must be correct. But let's see why. So she says the square root of 6.4 is equal to 2.5, or approximately equal to, and equal to the dot above it, approximately 2.5. And she's right. So let's see why. If I take a number line and I think about the square root of, back in grade 8, let's just say instead of 6.4, the square root of 6 would have been a grade 8 question. If you were estimating it using a number line, you're going to put the two perfect squares that the square root of 6 is between. And in this case, the square root of 6 would be somewhere between the square root of 4 and the square root of 9. Now, since the square root of 4 is a perfect square, it has a root of 2, and the square root of 9 has a root of 3. So right off the bat, I know that the square root of 6 will be 2 decimal something, right? And in order to kind of hone in on what this something is, we use the number line to approximate it. So if I was to break this up 4, 5, 6, 7, 8, something like this. 5, 6, 7, 8. This would be the square root of 5 here, square root of 6 here, square root of 7 would be there on the number line, square root of 8 would be here, and then of course the square root of 9. So square root of 4, square root of 5, all the way up to the square root of 9. If I was to kind of approximate where it would be on the number line, that's how it would look. So therefore, the square root of 6.4 is approximately there, right, which is almost right in the middle. And therefore, the square root of 2.5, or the square root of 6.4, is reasonable to have a square root of 2.5. Question 2 says, without calculating any square roots, identify the square roots that have values between 4.5 and 5.5. So the hardest part of this question is actually figuring out what it means. So I'm going to put an x here, square root of x, and the square root of y. Square root of x is going to have a square root of 4.5, and the square root of y is going to be 5.5. So now we have to figure out what number has the square root of 4.5. Well, let's pretend that it wasn't 4.5 and it was just 10. What number has the square root of 10? The answer would have been 100. 100 would have been the value of x, correct? But if we go back and say, oh, and by the way, I got that by taking the square root and multiplying by itself to get 10. And if I go back in time to what the original question was, what number has a square root of 4.5? Well, if I want to know what x is, That's not what I wanted to do. I could simply take my calculator and say, what is 4.5 squared, or 4.5 times 4.5? And the answer is 20.25. So what's going on with that now? Yeah. Therefore, x is the square root of 20.25. And that's, I'm scared to erase here. I'm having technical difficulty, so I just erase that there. So if I think about over here with y, and I think about the same thing, what square root has a square, or what number has a square root of 5.5? If I grab my calculator and go, what is 5.5? Instead of multiplying by itself, I'm going to actually use the square button. It's 30.25, so 30.25. So now that I've interpreted using this number line, I know that any number that is between 20.25 and 30.25 will have a square root between 4.5 and 5.5. So if I think about this number right here, 21.3, since that would fit between here and here, roughly maybe here, I don't know, we'll say that, its square root should be between 4.5 and 5.5. So we go 21.3, 21.3. What is the square root? It is between 4.5 and 5.5. It's 4.6. And then, therefore, this would be between there. This would be between there, and this would be between there. So those four numbers, if you plugged them into a calculator, should have a square root between 4.5 and 5.5. Question number 5 says, use the diagram to identify a rational number with a square root between 3 and 4. Well, if I take this square right here, and I'm just going to draw it right here and bring it down. Oh, no, we're going to bring it, there we go. If I think about this side length, it's 3, and its area is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 centimeters squared, and the area, or the length, is 3 centimeters. If I bring this bigger one down, I grabbed it, look at that, perfect. It is 4 by 4, so it's 4 centimeters here, with an area of 16 centimeters squared inside. And then if I let's use green this time, and I take my dotted line, okay, and I bring this over here. This would be 3.5 centimeters long, because it's 3 plus an additional half. And its area would be right between 9 centimeters squared and 16. So if I was to draw my number line, the area of this would be right in between there. So if I'm approximating it, I'm going to say maybe 12.5 or so. So I would guess is approximately 12.5 centimeters squared, because that's be halfway between 9 centimeters squared and 16 centimeters squared. If I grab my calculator and say, what is 3.5 squared? It's 12.25, which is pretty freaking close to the actual answer. Question number 6 says, identify a rational number with a square root between 0.7 and 0.8. So identify a rational number whose square root is between 0.7 and 0.8. So if I think about the two numbers that actually have those square roots, I'm going to do exactly what I did in the last question. I want to figure out what this number is right here, and what number this number is, and then I can figure out anything between. So if I want to figure out the square root of what number is 0.7, I take my calculator and say, what is 0.7 times 0.7? And it tells me 0.49, which makes sense when you think about it. So the square root of 0.7 is 0.49, and I bet you the square root of 0.8 is 0.64, keeping the pattern alive here. And we'll just double check. So 8 tenths times 8 tenths is 64 hundredths. Or if you think about that, 8 tenths times 8 tenths equals 64 hundredths, which is 0.64, and that's why it works. So if we think about that way, then any number that's between this number and this number will have a square root of in between this number and this number. So if I choose one, and I'm just going to choose the very next one, which would be 0.50 or 0.5 or just a half, right? If I take what is the square root of a half and press the square root button, it tells me 0.707, 0.707, which is between, and I can put some insignificant zeros here if it helps you, in between those two. If I choose something more like 0.58, the square root of that one, if I double check it, should be between 0.7 and 0.8. So the square root of 0.58, yep, fits between those two. So any number that you chose there's infinite possibilities actually, because you can use as many significant decimal places as you want. But those are a couple examples that do fit between them. And the last question for this particular video, estimate and calculate the number that has the given square root. So the hardest part about this is knowing that this is the question. The square root of what number is 3.1? Right? If this question had have just said, if there was no preamble and it was just this question, it would be much easier than the way it's written, because the interpretation is really the hard part. And again, if you're having difficulty thinking the answer, just think, well, the square root of what number is equal to 3? Square root of what number is 3? The answer is 9. What did you do to get 9 here? You just took this number and multiplied by itself to figure out what this number must have been. So based on the easier one, I'm just going to take 3.1 and square it like that at 9.61. So therefore, square root of 9.61 is equal to 3.1. And again, I could just reverse it and just put 9.61 in. 9.61. What is the square root of that? It is 3.1. For B, the square root of what number is equal to 12.5? Take my calculator and go, what is 12.5 squared? It should be more than 144, and it is 156.25. And for C, the square root of what number is equal to 0.62? I'm simply going to take 0.62 and multiply by itself. So I'm thinking it's like, I don't know, 0.3-ish? 0.3844, 0.3844. And finally, D, square root of what number is equal to 0.29? So 30% of 30 cents, it's going to be around decimal 1, I would suspect. But we go decimal 29, 29% of 29 cents is 0.0841.